Welcome everyone, my name is Claire Longo. I'm a lead AI researcher and developer advocate here at Comet. And today I'm going to be talking through a hands-on tutorial of one of my absolute favorite features that we just released. We're going to talk about how to evaluate agentic AI systems. But we've made this very easy to do in Opik, and today I'm going to show you how to do it. Okay, so the example I'm going to go through here is actually from the Google Agent Development Kit, the ADK. They have a great repo, which I'll link down below, that has a ton of pre-built agents that you can run yourself on your own machine. I've found this a really valuable resource because I was looking for a kind of complex multi-agent system that I could use for an example of how to log the conversations and evaluate them. So what we're looking at here is the agent graph. This is actually logged to Opik, and I'll show you all how to do that. But what the agent graph is showing us here is this is a 4-agent system. So a single interaction with a user could result in multiple agent calls here. Now, imagine you're a developer working on building an agentic AI tool like this. A lot of you watching this probably are. You're not just building a single purpose tool, it's a complex user journey towards an end goal. And it takes a lot of steps to get there. And those steps involve a lot of different things like tool calling or LLM calls. And the exact steps to get the user what they're looking for out of the system is not always predictable because these are non-deterministic systems. So there's a couple challenges that us as engineers and data scientists have when we're building these complex systems. We're typically not the end user, and sometimes we're building in fields or domains that we're not the expert in. And yet what I've realized is some of the most effective developers or AI practitioners in the field are the ones who actually understand what they're using. They understand the business use case for it, they understand the user journey. And these AI practitioners, they kind of have an edge because they're really understanding not just the tech of what they're building, but the actual impact and the user journey. And this deep understanding helps them craft a really effective system. But what happens when you're working in a domain that you're not really familiar with? Personally, I'm not a financial analyst. I can't look at the inputs and outputs of this specific system and tell you whether it's good or not. I just have to trust the output. So the truth is that the human subject matter expert is actually the best evaluator when it comes to AI systems actually doing the right thing. So the key challenge becomes, how do we actually capture that domain expertise and turn it into reliable signals so we can build better AI designs? First, we really want to collect human feedback. We need those subject matter experts. I need to talk to them. I need to see how they're labeling the inputs and outputs so that I can learn about my domain that I'm building for. And they need to apply their expertise to really guide the system. So once we have that human in the loop kind of feedback collection system in place, we then need to find a way to integrate that learning into the software, the AI system, so the system can start to improve over time or detect issues that a human would detect. Okay, now before we dive in, there's another challenge that we need to address with building these complex agent systems. We don't want to just evaluate a single step. We actually need to evaluate the session as a whole. The overall issue here is that we don't want to just evaluate the steps. We need to evaluate, was the goal of the session completed? We can evaluate each step. I feel like in the industry, we've kind of figured out how to do that pretty well, but those steps don't tell you if the overall goal was actually accomplished and the user is satisfied. To truly understand the quality of what we built and the impact on the users, we need to evaluate a full session end to end. So Opik has recently introduced a purpose-built annotation flow at the thread level for conversations. It's designed to specifically support human-in-the-loop workflows and allow you to scale that out into a more automatic feedback collection process that you can scale and improve your LLM agents automatically. I'll quickly run through a few of the concepts that you're going to see in the live tutorial. First, we have the concept of agent traces. This is a multi-agent system. You saw in the graph earlier that there's about 4 agents here with different specific tasks, and then an orchestrator agent that is executing those tasks, compiling a final output. So there's probably 5 calls to an LLM, if not more here, depending on how you trace through the flow as the user. What we need when a user goes through this flow is we need a ability to log every step that they took. This is really critical if there are any issues, if we identify any bugs. We obviously need logs with inputs and outputs so that we can use that in the debugging process. And we also need to identify areas for improvement or areas where the system was working really well or even costing a little or a lot money. Just having that great visibility into how your agent is performing and how much it's costing is very important. the agent traces will collect all the multi-agent calls into a single trace and create a graph so you can actually visualize your entire agent system in Opik. So what we're looking at here is a single log through the entire agent system. Next is conversation threads. So we want to log a conversation, like I mentioned before. It's not just a trace through an agent, but it's actually the user and AI interactions in the conversation format. And conversations are a little bit strange in this format because a user could leave for a little bit and come back and still continue that conversation. So we need a way to actually group all these LLM calls, traces into one single conversation under a single ID so that we can actually trace the user's experience through our entire system. And these conversations may include many agent interactions within them. Next, we need the ability to interact and label things as humans. So Opik has created this great method for collecting human feedback within the UI. The developer could do this, or our vision is we do think a lot of product managers or subject matter experts, potentially even end users, will be interacting with these systems and providing feedback. So as the humans are labeling your data, you are actually collecting a data set of good and bad examples that you can use to improve your system over time. And the human's reasoning can be collected as well. Then once you start collecting a lot of human feedback, the next thing is to start to automate how you are labeling and evaluating your system. So the way we recommend doing that is with LLM evals. We have designed a thread level LLM-as-a-Judge metric. So before we had LLM-as-a-Judge metrics across the traces and spans, but the conversation can now be an entire thread, and you want to evaluate that goal that we mentioned overall. Not just like, was this LLM call successful? Did it hallucinate? But stepping back and looking at the entire user experience, the entire conversation. Did that user accomplish their goal? Are they sad? Are they mad? Are they angry? We want to know how they feel. And so an LLM eval at the thread level is going to give us the ability to automatically measure that. We can base it off of the human feedback that we collected so that we can start to detect the kind of issues that a human would detect if they were manually inspecting each trace. So thank you so much for sticking with me so far. Now for the fun part, I'm going to jump into actual real code here and show you how this works live. Okay, now let's jump into some fun code. So what you're looking at here is my Cursor developer instance. I am working in Cursor almost every day. I love doing AI assisted coding, but there's a ton of wrong and right ways to do it. So if you're interested in learning more about that, that's a different topic. I have a blog post on it that I will also link. But I found this to be hugely effective. So I'm typically working in Cursor every day. And what I did today is I ran this financial advisor agent demo from Google. I chose this example because it was one of the most complex agents that I could find in the repo. So here's why. It's a multi-agent system. So you can see in the structure here, financial advisor. Let's take a peek at what's inside there in an organized way. So the first thing to notice is that there is these sub agents and financial advisors. So the financial advisor itself is in this agent.py, and that's where I'm importing Opik, and I'll talk you through how I'm doing that. But notice first that the financial advisor is a coordinator, and it's making calls to 4 different agents. And then in my sub agents folder, you can see those 4 different agents. They all have different specific jobs. So each one is its own call to a LLM. So we've got a data analyst, execution analyst, risk analyst, and trading analyst. So it's really like a full team is working for you here. But let's take a peek at how I did the Opik integration. And this is how I log the traces that I'll show in the UI. So it's really just a few lines of code to log the traces from Opik. I'm using the ADK integration, which is a automatic integration with the Google Agent Developer Kit. So we already know what the inputs and outputs might look like, and all you have to do is just layer in a few lines of code, pip install Opik, and we're going to start automatically logging your traces, as well as create that beautiful agent graph. So I'm using the Opik tracer, which is the ADK integration, and I'm also using something called track ADK agent recursive. So what this is doing is this is tracing the multi-agent system. Those 4 agents need to be kind of grouped together as like a single trace so that we can see a trace that runs through the entire process where those calls are made out to all 4 agents. And that's what is helping us create that beautiful graph. So this is our code, and when I run it and interact with it, a trace will show up in the Opik UI. So let's go take a look at that. Okay, now let's hop into the Opik UI and see what these traces look like now that they're logged. So you can see I've been working on quite a few projects here, but the one of interest is the Financial Advisor ADK. So when you first log into Opik, you'll see all your projects, but let's click into the one at hand. And the first thing you're seeing here are the traces. These are all the agent traces that we've logged so far. And the first thing I want to point out is that the columns here are configurable. I personally love to keep an eye on number of tokens and costs. So those are two columns that I always include here just so I can get a quick bird's eye view of what this is costing me in development or in production. But you can toggle things on and off here. So if you don't care so much at cost, you really just want to get a good view of maybe inputs and outputs, maybe you don't care about tokens, but very configurable just to give you that view to help you quickly see the patterns that you're looking for. Now let's click into one of these agent traces and see what they look like. So what we're seeing here is a trace through that agent system. Remember, there was that financial coordinator, which is our kind of general agent that is sending tasks out to these sub-agents. So we see our financial coordinator here, but we also see a few sub-agents that were called. So the execution analyst, as well as the risk analyst. And the great thing is that these are calls out to different LLMs. I'm actually seeing cost. So I'm tracking the cost as well as latency on these LLM calls. When you click into the spans within the trace, like the spans for the LLM call, you also get a view of metadata around the model. So this could be really useful if I'm maybe iterating with model type or parameters and want to track more information around that. Again, customizable here. So that is what an agent trace looks like. But the agent trace itself, you can see the inputs and outputs here. That's quite useful, but it's not as useful unless it's in the context of a conversation. So let's take a look at the conversation traces. So the conversations are traced within a conversation thread. I've had 1, 2, 3, 4, 5 conversations with this financial analyst agent this morning, and I've been logging all of them. So let's click into one of the conversations. So now what I'm seeing here is that actual user AI conversation interaction, and I can still link back to the traces related to this conversation. So if I'm a human labeler and I want to review this and make sure that the system is giving good financial advice, or I'm maybe looking for user frustration or misuse, maybe the user is asking for stuff that's not financially related, I'm using kind of my human eyes to scan this very interpretable AI user conversation, and then I can label it. And while I'm doing this inspection, I can also link back to those exact traces that I showed you earlier. So any label that I assign to this is still going to be correlated to those exact traces. So if I do detect an issue here and label it for my developer to review, they're going to be able to look at the actual technical traces and trace it back to maybe a model type or a broken routing call, tooling, whatever it is. But as a human in the loop now, I can start labeling with feedback scores. So let me show you what that looks like. So you can create your own human feedback definition. This is totally customizable. I have a very simple no, yes, but this could mean is the user frustrated? Are they not? Is this sound financial advice? Is it not? You can name it whatever you want and set what the labels are. But just as an example, I just have this human feedback metric. I can label this one. And then when I go back, I will see that metric here. Now there's some other metrics showing up, which I'm going to talk about really soon, and those are the LLM-as-a-Judge metrics. But before I go there was a really cool feature for conversations that stood out for me. Notice right up here, that little icon that says this is an inactive session. Now you can set what an active or inactive session is. And the reason this is really useful for conversations is imagine you're using an AI chatbot and you're having a conversation with it. Imagine you go do the dishes or take a phone call or something, and then you come back and continue that conversation. Well, in terms of actually evaluating the quality of that user experience, that's not necessarily a new conversation. So we need a way to kind of group things together so that the user and developers can really kind of interpret a concept of a conversation here. So with this being an inactive session, that means that it's not an ongoing conversation. This is one from earlier this morning around 10 a.m. But we can actually configure the thread timeout. So I have mine at 5 minutes, but depending on how you feel like users might be using your system, you could go all the way up to 1 hour, which allows people to take time, get coffee, and continue their conversation with your AI. And you're still going to be considering that user AI interaction within one conversation thread. Okay, so we've solved a few problems here. We can log complex agents with multi-agent interactions, and we can group things into a single conversation under a thread ID. Great, but I still need a way to really automate how the system is learning over time. I have the human in the loop labeling things, but that human might not be able to label all my data. That might get very expensive, or my human might get very tired. So I need a way to really automatically figure out if the system is behaving in a way that the human would label as good, but I want to do that at scale across every conversation. So a way to do this that Opik really facilitates the workflow in the UI here is once you've curated that human feedback, your developer can start to look at it and learn from it and correlate it back to technical details, because your conversation is still relating back to your agent trace. So the developer might start to see patterns of like, oh, the user is getting really frustrated, and it's always when this like one LLM call takes like a really long time. So the developer is learning from the human in this feedback loop. So if you have your subject matter expert that's a financial analyst or an expert like customer support person, the developer is looking at the human feedback and learning really that kind of like domain knowledge that they needed to build out a good system. Now the developer wants to incorporate that into the system in a way that the system can start to improve over time. So that's where my favorite concept, LLM-as-a-Judge, comes in. I've created a LLM-as-a-Judge metric for user frustration. So very quickly, what is LLM-as-a-Judge? LLM-as-a-Judge is where you're having an LLM judge the output of your original LLM. So it's an LLM metric, and essentially all it is a prompt, but it is forcing an evaluation of the output through the prompt, and it's forcing the output to be in a very exact format that casts it into a metric. Because when we think about monitoring these systems, I want a metric that I can track over time. I want a pretty graph where I can see if things are like increasing or decreasing. And that's really hard to do if I just have like an LM telling me if things look good or not. So I'm really forcing this to become in a JSON format. I want it to either label happy or mad. You could be creative with this. 0-1 would probably be more appropriate, but we're having some fun here. But we're really looking to see if the user is frustrated. So the LM is going to look at the conversation overall. And one thing to point out is that this is a thread level evaluation. You can also do trace level, span level. But as we mentioned earlier, like evaluating the different steps in this flow is really not enough to evaluate the entire goal. So the LLM-as-a-Judge metric is telling us, was this user's goal overall accomplished? In this case, I want my user to be happy, not frustrated, because that means something probably broke. But you could also evaluate if they received sound financial advice, if it was actionable, whatever it is specific to your business use case. Because this is just a prompt, it's totally customizable. So you're able to evaluate and actually measure with a number or label the exact issues that might be unmeasurable with a more heuristic metric. All we have to do is create this metric, and I placed it on my thread. I could do a sampling rate. I have it at 1, which is fine for now. You choose the model, you have a whole bunch to choose from, and you can mess around with the temperature. One thing to notice is I am evaluating with OpenAI GPT-4o, but my agent is built on Google and making calls to Gemini. I actually did that on purpose. I really like evaluating my LLM systems with a very different LLM model because it adds a little bit of an additional perspective. So all I have to do is create that rule. And then when I log new conversation threads, those labels are going to show up right here. So here I'm detecting if the user is happy or mad. And let's click into one where the user is a little bit mad and take a look at what that feedback score looks like. So what I see here is like my system's actually not working. The agent is not replying. The customer is trying to say stuff to it like, hey, can you look at the Apple stock? Give me some information about it. And it's not giving any output. So the user is becoming increasingly frustrated. And we actually see our LLM-as-a-Judge metric pick this up, which is awesome. So we're given a reason, the user repeatedly provide input without receiving a response, and that's why we flag this one as like level 8 for how mad this person's getting. This is a really, really useful way to automatically detect what maybe a human could detect by visually inspecting the conversations. So essentially what we've seen here, going back to our agent trace for visualization here, is we've seen that we are able to log agents end-to-end, complex agents, and see all the steps within the agent trace. And we've also shown that we're able to group conversations, even under nuanced conditions where a conversation might include long pauses or a user returning later. And then we have a human in the loop feedback labeling method so that we can actually involve our subject matter experts and have them improve our system by telling us where it's working and why not. And then finally, as a developer, we're able to take that feedback, learn from our subject matter experts, really kind of put ourselves in the customer's shoes and create an LLM-as-a-Judge metric that emulates detecting what a human might detect on when they do their visual inspection and labeling. So what we've really shown here is that full approach to building a system, understanding your use case, and then being able to measure its impact and monitor it over time. The last thing I'll show you is the metrics tab. I've only been running this thing a few times this morning, so not a lot of cool trends to see here. But if this system was live, you would start to see some really helpful trends over time. We can graph the number of threads, thread duration, number of traces, trace duration, estimated cost, which is my favorite one across personal projects. And then also you can start to see a graph of those feedback scores. So this takes you fully into that monitoring at scale, where you're not just running a few examples, inspecting the output, maybe tinkering with things and trying to get that model ready for production. Once it is in production, you're going to start to see these live graphs of the metrics that you've been using for development over time. Amazing. Thank you so much for joining me for this tutorial. If you'd like to see the code and reproduce it yourself, I will link it down below. And if you'd like to start using Opik, it's totally free and open source and fully feature functional. So if you'd like to get going with it today or give us a star, I will also drop a link for that. I hope to see you again in another video soon. Bye.